Today, we are going to go over solving quadratic equations, and we are going to focus on 3 different methods in order to solve for the variable. So our variable in number 1 is r. We want to find out what r equals, not r squared. We're finding out what r equals. And so quadratic formula is going to utilize a, b, and c in this formula, and in this case it's going to be r equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Typically this value is x, but because this equation starts with or includes the value r, we are really solving for r based upon the variable here. That's why I'm writing r and not x. So a is 1, b is 10, and c is negative 56. Just in case you wanted to know where I got those values from, a is going to be the coefficient of r squared, b is 10, that's the coefficient of r, and c is negative 56, that's going to be my constant. And I pull these values a, b, and c when the equation is set equal to 0. We cannot pull these a, b, and c values out until it's set equal to 0. Our quadratic equation, this is a quadratic formula. This is the quadratic formula. This is an equation in quadratic form. And that form, one more thing that we can cover, that form is ax squared plus bx plus c equals y. In this case, it equals 0. That's why we're solving for the variable r. All right, so now we're going to plug these things in. So it's the opposite of my b value plus or minus the square root of my b value squared minus 4 times a times c all over 2 times a. And we see inside this quadratic, or inside our square root, we're going to get a big number. We're going to get some pretty large numbers. So we're going to simplify this expression. So 10 squared, it's plus or minus. 10 squared is 100. Negative 4 times 1 is negative 4 times negative 56 is 24 is 224 over 2. And now we're going to simplify plus or minus. 100 plus 224 is 324 over 2. I'm going to use my calculator. 3, 2, 4. I'm going to see if it's a perfect square. It is 18. Who'd have thunk? Negative 10 plus or minus 18 over 2. And now we are going to separate into the two situations, when 18 is positive and when 18 is negative. That gives me 8 over 2, which equals 4. This gives me negative 28 over 2, which is negative 14. So my solutions, in a solution set, we're always going to do the smaller to larger. So my solutions to this equation, the only two values that can go in for the variable r are negative 14 and 4. Those are the only ones, when we plug in and simplify, is equal to the right side. Here's question number 2. Here's question number 2 that you can write down if you're playing along at home. Remember, our first thing is it needs to be set equal to 0. So we're going to subtract 12, and we get 3p squared plus 9p plus 6 equals 0. So keeping track of the different techniques. Here we're doing quadratic formula. We want to move our constants to the left. Be aware that when we are completing the square, we may move them in a different direction. So that's really important to be very, very familiar with what you're doing and why you're doing it. And what are we pulling from that equation? So Since it's set equal to 0, we can now find and pull our a value, which is the coefficient of p squared, our b value, which is the coefficient of p, and c, my constant, which is 6. And we're going to plug it into our quadratic formula, which I don't mind rewriting each time. And now I'm looking and plugging in the appropriate values, the opposite of b, plus or minus b squared minus 4 times a times c, all over 2 times a. Gives me -9 plus or minus 81. -4 times 3 is -12. -12 times 6 is -72, all over 6. -9 plus or minus the square root of 9 over 6. 9 is a perfect square, so I get -9 plus or minus 3 over 6. Let's separate these into two situations, -9 plus 3 over 6 and -9 minus 3 over 6. -6 over 6 gives me -1. -12 over 6 gives me -2. So my answers are -2, -1, smallest to largest in my solutions. The third one, not equal to 0, so we're going to subtract 55. 4x squared plus 9x minus 55 equals 0. Oof. My c value is quite large. A, b, and c. Opposite of b, plus or minus, square root b squared minus 4ac all over 2a. Opposite of b, plus or minus, square root of b squared minus 4 times a times c all over 2 times a. That doesn't look very fun, especially without a calculator. -9 plus or minus the square root of 81 is going to be plus. I don't even have to do any multiplication to know it's going to be plus. I have a -4 times a +4 times a -55 is going to give me a positive value. I don't know what it is yet, but I know for certain it's going to be a positive value. So 4 times 4 is 16. 16 times 55 gives me 880. 880 over 8, 2 times 4. We get -9 plus or minus, ooh, that's 1. 8 and 8 is 16. 961? Ooh, that is not 961. Is it a perfect square? Oh my goodness, that is crazy. How nice is Mr. Mac to give you some very nice, what do we say, 31? 31 over 8. Let's separate them. -9 plus 31. You'll notice that I always do the plus value first. -9 minus 31 over 8. This plus or minus, and something to make sure we understand, that plus or minus is only affecting the 31. It does not affect the 9. So -9 and 31 gives us 22 over 8. Ugliness for, now 2 goes into it, 11/4. I like that. That gives me -40 over 8, which gives me -5. So my two solutions are -5 and 11/4. No need to turn it into a mixed number. We're not graphing it on a coordinate plane. I'm going to go back here and just make sure that that is correct. That's good. And half is 11, and we can't reduce 11/4. I think that's pretty good. And the last one looks pretty straightforward. Looks very straightforward. A equals 1, B equals -12, and c equals -4. You would think that, hey, this is going to be a nice, easy one. Let's check it out. Opposite of b, plus or minus square root b squared minus 4ac all over 2a. Opposite of b. All right, there's something that's interesting. Plus or minus the square root of b. That b is negative, so I need to include it, a parentheses in it. Minus 4 times a times c all over 2 times a. So the opposite of -12 is 12. Plus or minus -12 squared is 144 plus 16 over 2. 12 plus or minus 144 plus 16 is 160 over 2. Now 160 is not a perfect square, but it does have some perfect square factors. 16 times 10 all over 2. Don't mind that coughing, that's not me. I'm kidding. We get 4 rad 10 over 2. Some students would leave that. That would be a mistake because this can be simplified. And the reason why it can be simplified is because all 3 coefficients, we don't care about the things on the inside, we're just talking about the outsides. Because we can only simplify outsides with outsides. We can only simplify insides with insides. There's only one number inside and we've simplified that already. So now we're looking at the outsides. And when we look at the outsides, all 3 have to have a common factor. All 3 of them. So what goes into 12, 4, and 2? 2 does. 2 goes into 12 6 times. 2 goes into 4 2 times. And 2 goes into 2 1 time. Now this would be a mistake also. We can't leave a fraction over 1. We know that anything over 1 simplifies to that number. So this is our solution. 6 plus or minus 2 rad 10. There's no benefit of us separating it into 6 plus 2 rad 10 and 6 minus 2 rad 10 because those are unlike terms. We cannot combine 6 with the 2 because it's being multiplied by rad 10 and we can't add before multiplying. So that is going to be my answer. And that, oh, let's go back to this. Let me show you an example. If I had 3 plus or minus rad 6 over 12. Ooh, that's a good one. Can I simplify that? Can I simplify that? No, you cannot. How many pieces are there? 3. Yes, one of them is invisible. One of them, you are pleasantly forgetting that there's a 1 there. So no number goes into 3, 1, and 12. This is a big, big trick problem. Most high school students would get this problem wrong. Most high school students would write this as their answer. This does not equal 1 plus or minus rad 6 over 4. You cannot cancel the 3 and the 12 because there is a 1 here that we need to address. So these do not equal each other. No. That cannot be simplified. Your answer is just 3 plus or minus rad 6 over 12. It pains people. And the 6 can't be simplified because that's inside. So it pains people not to be able to simplify that. Now, this is an addendum. Here we go, Algebra 2. You can rewrite this. Ooh, do I want to do that? Yes, you can. So you can do 3/12 plus or minus rad 6 over 12. That's acceptable, and then you can reduce this 1/4 plus or minus rad 6 over 12. But do you see how ugly that is? It's not as elegant. It's not as beautiful as that. This is the most elegant. That's how most high school teachers, college teachers are going to want to see it. But that is equivalent to it. You put the 12 under each of the pieces, under that piece and that piece. These cannot, because one's in the radical, one is out. So that would be an acceptable answer. You really wouldn't see that very often. So we got a little sidetracked with that. So let's keep moving on, shall we? We shall. Now it says you must isolate the square root. Okay, that's pretty simple. You have m squared equal 1. What gets rid of the square above the m? We are going to take the square root. Whenever we take the square root of a variable being squared, we must introduce plus or minus. And what we do to one side, we're going to do to the other. We're going to take the square root of the left side. We have to take the square root of the right side. Square root of m squared is m. The square and the square root cancel, hence why we are taking the inverse of the square, which is square rooting. And we get plus or minus 1, because the square root of 1 is 1. So my answer is plus or minus 1. Nice and genteel, easy, simple one. Let's isolate n squared before we take the square root. So we're going to subtract 6 from both sides. You get n squared equals 100. We're going to take the square root of both sides. Whenever we take the square root of a variable being squared, we have to input plus or minus. Square root of n squared is n. 100 is a perfect square. So we get the square root of 100 is 10. Plus or minus 10 is my solution. These are pretty straightforward, pretty simple, until we get something that looks like this. So we're going to subtract 1. Our variable is not isolated yet. We have to divide by 16. We have isolated. We have solved for the squared root. Now, what gets rid of an a squared is a square root. So we're going to take the square root of both sides. That equals a. And much like when we broke down our 16 here, where's our 16? I think it was right here. How we broke down the square root of 160. We can break things into multiplication in their own house. That's legit. We can do that. We can also do it with division. So we can do it with multiplication and division. So I'm going to put this under its own house, the numerator under its own house, and the denominator. No, because I couldn't simplify this fraction. You see that 25/16. No number goes into 25 and 16. So that fraction's reduced. But we have a square root, and I notice that those are perfect squares. So I don't want yellow. I want to go back. So we get a equals plus or minus square root of 25 is 5, square root of 16 is 4, and that is also reduced. That fraction cannot be simplified. Turning it into a mixed number is not simplifying. That's converting. And I don't need to convert. An improper fraction is okay. Let's get rid of things being added and subtracted first. I almost made a mistake there. We get 6x squared equals 48. Divide by 6. We get x squared equals 8. 6 times 8 is 48. We're going to take the square root. Plus or minus, rad 8. 8 is not a perfect square, but we can break it down into rad 4, rad 2, and we get plus or minus 2 rad 2 as my solution. Did I do the other one in a? Yes, I did. Just want to make sure I did it in a solution set. Plus or minus 2 rad 2 is my solution for that one. Those are pretty straightforward. That's probably going to take you about a nanosecond to do those 4 problems. Now, you must use completing the square. So completing the square, we look, does this constant, is it the proper constant for the completing, for a binomial square of that b value? That is no. So let's move this constant out of the way, because 63 does not, that left side does not break into a binomial square. So we get n squared minus 2n equals 63. Now the question is, what value here would make it a binomial square? What value would allow me to write it like that? Well, you take half of my b value, half of -2 is -1, and -1 squared is going to give me +1. So what I do to one side, I have to balance it and do it to the other. But if I saw n squared minus 2n plus 1, I can factor that into a binomial squared. N minus 1 quantity squared equals 64. Now I have my variable being squared. I know how to get rid of a square. I'm going to take the square root, and whenever I take the square root of a variable squared, I'm going to do plus or minus. These cancel. The square cancels with the square root. Leaves me with n minus 1 equals plus or minus 8. And then now we have my variable. I'm going to isolate it. There's a -1 that I need to get rid of. We are not going to simplify this like this. I see students do this too. Ooh, that does not equal plus or minus 7. That's a big mistake that students make. No, that equals 1 plus or minus 8. So we have to separate that much like we did with our quadratic formula. So I get 1 plus 8 and 1 minus 8. That gives me 9 and -7. So far from that sort of assumption. And we're going to put them in numerical order. And I get -7, +9. Okay? Very important, understanding that our plus or minus goes after. This 23 does not make this a binomial square. So I'm going to subtract 23 from both sides. X squared minus 8x equals, what's that? 3, that's -15, I think. So now we ask ourselves, what constant do we need here to make this a binomial square? So we're going to take half of my b value, which is -4, and square it, which is 16. So what I do to one side, I have to do to the other. And now I have produced a binomial square. That half goes right in there. Quantity squared equals 1. So very nice, very easy. Now we're going to take the square root of both sides. We get x minus 4 equals plus or minus 1. Square root of 1 is a perfect square. We're going to add 4 to both sides. We get x equals 4 plus or minus 1. 4 plus 1, 4 minus 1. So we get 5 and 3. Let's write it in numerical order. 3 and 5. Number 11, we're going to subtract 8. B squared minus 12b equals -12. Half of 12 is -6. Quantity squared is 36. What I do to one side, I have to do to the other. This becomes b minus 6 quantity squared. And -12 and 36 gives me 24. Let's take the square root. Sorry, quantity squared equals plus or minus square root of 24. That gives me b minus 6 equals plus or minus rad 24. That's not a perfect square. So I need to simplify that. So before I move my -6, I'm going to break that up. I know that 4 rad 6. So that's b minus 6 equals plus or minus 2 rad 6. Now I can add my 6 over. And it doesn't matter really when you do it, but it's going to be a whole lot easier and less convoluted if you do it then. So if we separate it, it doesn't matter. 6 plus 2 rad 6 can't combine. Those are different. Those are unlike. One's a number, one's a coefficient with a radical. They can't add or subtract. So that's my answer, 6 plus or minus 2 rad 6. We would not be able to leave it as rad 24 because rad 24 can be simplified. And the last one, we're going to add 50 both sides. we get n squared minus 5n equals 50. Ooh, notice our b is an odd number. So I'm going to take half of that. Half of negative 5 is negative 5 over 2. That's as easy it is taking half of a number. And now we're going to square that. So that's negative 5 over 2 times negative 5 over 2, which is going to give me a positive 25/4. What I do to one side, I need to do to the other. Now finding the binomial square is very easy. It's just half of your b. Just put your b value over 2, and that is going to be your binomial square value. Now 50 plus 25/4, I'm not changing 25/4 to a mixed number. I'm going to change 50 to fourths, which is 200/4. You should be able to do that fast. And we get n minus 5/2 quantity squared equals 225 over 4. That's relatively easy. Now I'm going to square root both sides because I got to get rid of that square so I can get into that variable. Plus or minus square root 225 over 4. That leaves me with n minus 5/2 equals plus or minus. I'm going to separate 225 and rad 4. N minus 5 over 2 equals plus or minus 15 over 2. I, at this point, remembered that 225 is a perfect square. I'm going to add 5/2, add 5/2. I have n equals 5/2 plus or minus 15 over 2. Let's write out each one. 5 over 2 plus 15/2 and 5 over 2 minus 15/2. That's 20 over 2, which equals 10. That is negative 10 over 2, which is negative 5. Oh, look at that. Nice, clean, beautiful solution. And we are done. And that probably took about, I'm going to say 26 minutes. It's going to be my guess. Come and see me if you have questions.